And welcome everybody to the Daily Space Weather. Happy All Saints Day, etc. Here comes some imagery of the sun. If you think there's competition for the channel, think again. This is 1700 angstroms. 3 sunspot groups to mention. 2887, 2891, and I think 2893 is the name for this one. We've got some additional coronal mass ejections happening. Check it out. Here is the LASCO C2 and C3. The C2 is the red part. The C3 is the blue part. If I had to guess, which I don't, I would say that ejecta will miss the Earth to the south. How do I know? Well, because that was located at Lagrange point 1. That's where the LASCO C2, the SOHO, is located, which contains the LASCO C2 and C3. Stereo A is located out here at Lagrange point 5. And there you can see most of the ejecta certainly looks like it's well off of the Earth line. So from this perspective, at Lagrangian point 5, the way stereo A is oriented, it would put Earth off to your right. And it's quite close to the ecliptic plane. So the ecliptic plane is right about here. And you can see that ejecta largely not on the ecliptic plane. The location of planet Earth. Here's our colorized magnetogram from the Solar Dynamics Observatory. We still have a solar flare warning in effect, folks. The likelihood of major flares remains, as these sunspot groups are both still beta-gamma class sunspot groups. Here's a great composite for you. This is 211, 304, and 171 angstroms all at the same time. We'll show you filament Pierre-Marie toward the end of the video. The radial flux has dropped down to 103 solar flux units. There's the 1-year chart to put it in context. It does need to be refreshed. Radial flux now down here at 103. So here's a space weather enthusiast dashboard, and we see no solar storms forecasted here. Actually, there is some geomagnetic unrest forecasted for this morning, but that's going to subside quickly. No geomagnetic storms in the forecast. Let's take a look at seismicity here. There's a 90-day bar graph, and you can see there is a bit of a 7 magnitude earthquake drought happening at the moment. If you're in an earthquake-prone zone, please have a plan for what may happen if buildings start to crumble. Largest quake of the past 24 was this 6.1 at the South Sandwich Islands. There is the location of that. And let's consult the USGS list to see what else has been shaken. All right, so a bit of an uptick there in seismic activity here over the past couple of days. Perhaps some of these earthquakes are foreshocks for larger events. There were some deep quakes happening, at least this 4.0 at over 330 kilometers estimated depth near Indonesia. 5.6 in the Aleutian Islands. A 5.1 at Japan, as well as another 5.1 near the island. I think that one might have been on land. 4.4 at Fiji, that was at nearly 500 kilometers estimated depth. The 6.1 came in early this morning at 2:51 Universal Time. 2:51 Universal Time there. That's 6.1 South Sandwich Islands region quake. And if we missed anything, let us know in the comments. Check it out. La Palma, the sights and sounds of the La Palma Volcano. And we've been showing clips daily of this. Let's see what else is going on. So we just showed you some explosive activity there. 11,000-foot ash plume created over La Palma. Karimsky exploding, 8,000-foot ash plume over Karimsky. That's located on the Kamchatka Peninsula there, east of Siberia. Subanose-jima, 6,000-foot ash plume from Subanose-jima. Mount Ibu exploding, 6,000-foot ash plume from Ibu. Dukono exploding, 6,000-foot ash plume from Dukono. Fuego exploding, 16,000-foot ash plume. Flight level 160 over Guatemala from Fuego. Nevado del Ruiz, volcanic ash not seen in satellite. It could be erupting. Don't assume it's not. Don't attempt to square dance around the caldera. Sangay exploding, producing a 20,000-foot ash plume over Ecuador, so that's an uptick at Sangay. Revenador in that same nation of Ecuador, also exploding, 15,000-foot ash plume from Revenador, flight level 150. Sabancaya exploding also, flight level 240, a 24,000-foot ash plume over Peru. Let's look at magnetic data. And you can see these spiky, sawtooth-looking patterns here on the GOES magnetometers. That's because plasma gets heated up and oriented to magnetic fields. It also has the tendency to block our ability to measure the magnetic fields, and that's what you're seeing there. That's a bunch of plasma showing up from coronal mass ejection, mainly, the one that occurred on the 28th of October. Next, the ecliptic plane field plot. Top view here. Earth is still in a North Pole-oriented current sheet shown in green. Nothing to write home about there. By the way, that helped to weaken the coronal mass ejection impact. Here's a line-of-sight ecliptic plane field plot. Also shows you the solar magnetogram. A great view from Earth's perspective of the polarity of the heliospheric current sheet. The sun's putting out a lot of protons, and they're oriented to one pole or the other, their magnetic spin moment. Here's a line-of-sight coronal hole plot, and you can see some North Pole-oriented coronal holes rotating in here to the Earth-facing zone. They are trans-equatorial. Cycle 25 still taking its good old time progressing. Not very well-defined coronal holes, I might add. Here's 193 angstroms. And as we just saw, this whole area over here is associated with coronal holes. They're not quite visible yet. There's a bunch of plasma in the way. The magnetic data does not lie, although many content creators, so-called content creators on YouTube certainly do. Next, our flare monitor and detected sunspot groups. Again, coronal mass ejection has just occurred. And a solar flare warning remains in effect here, as we've got sunspot 2891 especially, with rather complex fields still capable of producing major flares. Something to keep an eye on. And when I say ion, well, pardon the pun. Next, looking at flaring. We just saw an M-class flare happen this morning. Peak flux was around 140. Universal time, 1:40 today on All Saints' Day, November 1st. Now, that solar flare may have produced some relativistic particles. We did see an uptick here recently in the proton flux, so that could indeed be additional ejecta striking the geospace. Here are your ionospheric absorption predictions. Yeah, radio blackouts. And there's that M-class flare. You can see causing a radio blackout over Oceania there, a partial radio blackout over places like northeastern Australia. And you can see an increase here in the proton flux. So if you look at the color of the Antarctican region there, you can see it turns back to red right at the end, an indication that some relativistic protons have showed up once again from that most recent coronal mass ejection this morning. So radio blackouts will continue. Some bad times for high-frequency radio communication on Antarctica. And a roving blackout zone over the northern hemisphere since the 28th, only an hour after that X-class flare happened. And as we forecasted, these blackouts have continued for days. Great animation there of, and by the way, the reason that happens, folks, is because the incoming solar protons generally get associated with field-aligned currents around the Earth's poles, spiraling into them. They don't just strike the Earth, they strike the Earth's magnetic moment. Next, the real-time solar wind. Pretty uneventful over the past 24 hours, really. Current conditions are 8.6 protons per cubic centimeter for the density. Solar wind speed only 352 kilometers per second. Pretty much back to background levels. So we saw a brief period of geomagnetic storm here, a KP5 moment for about 3 hours or less. And about 9 hours of geomagnetic unrest shown in those yellow bars there. Current conditions are KP2, global geomagnetism at calm conditions. Next, the geospace over the past 4 hours here, magnetohydrodynamic pressure. Fairly homogeneous pressure here over the past 4 hours, at least as modeled by the space weather modeling framework. We'll also show you ground magnetic perturbations. And this is 4 hours of data as well. We're going to let that play through because it refreshed, and we don't edit these videos. We put them up as quickly as possible to get the information onto your screen and into your brain. So we see some perturbations here over both northern Central Europe, North America, Australia there, south of the Pacific Ocean. Probably indicating underlying structures in the Earth's geology. I'll just leave it there. Next, a chart of the solar system. This is where planets are located, and keep in mind, this is not to scale. There is no danger of Earth passing Jupiter or Saturn, or Jupiter and Saturn being aligned, or anything like that. This idea that planets do something in terms of like causing disasters on Earth and so on is just complete and total nonsense, backed up by absolutely nothing except a bunch of hack frauds on YouTube cashing in on people's ignorance. Anyway, there's where things are located today. Let's advance this 1 week. There's your 7-day planetary forecast. Here's a star chart. I like to use in-the-sky.org. And the sun will pass over the galactic plane as it goes from Gemini to Taurus today. The yellow line here is the ecliptic plane. And the moon should be visible here if skies are clear in Lehigh Valley, Pennsylvania. Let's do a brief cosmology segment. How about the Milky Way galaxy and a waterfall? Well, there you go. That's apod.nasa.gov. The astronomy picture of the day. I have no idea where it's located. If you want to find out, go find out yourself at apod.nasa.gov. And let's pick a quote, random and quote object. This one's not random at all. It's the first one. Number 1 on the Neil Gehrels Swift Observatory. The first transient you'll find there is Quasar B0003-066. It's a full spectrum quasar. And there you can see the 16 years of X-rays, hard X-rays from this quasar. It's a pretty consistent X-ray source. There's the 30-day chart in the lower left. And by the way, if you click on Simbad, you'll find a link on that page to click on the CDS portal, which is where we are now. If you look at the photometric points, you'll see that it is pretty bright here across most of the electromagnetic spectrum. When I say electromagnetic spectrum, I mean light, everything from gamma rays down to radio frequency, photons. Let's take a look at this in some different bands. So this is pan-stars, optical bands Z and G. And we'll zoom in on this distant galaxy, which has one of its galactic jets oriented toward us, the observer. Anyway, there it is, an optical light. Let's take a look, see if we can see it on the infrared. I like to use the 2MASS. And there is the color imagery from the 2MASS. That is infrared light, by the way. And you can see it's in a pretty cold portion of space there, yes. Cold portion of space. How about in ultraviolet? And there's a pretty high-res image in ultraviolet light, the combined swift UVAT intensities. Not a very bright portion of space in ultraviolet either around that quasar. And the X-ray data on this is not the best. There is some X-ray data from that quasar. Anyway, that's today's featured object. Again, quasar B003-066, a full spectrum quasar. And that's today's cosmology segment. We integrated it to the Daily Space Weather video. Check our playlists for hundreds of additional cosmology segments. We saw some charging hazards earlier. They have subsided since I did show prep. By the way, if you want to read about that, just click on the link. It's CSERT. SEAESRT. You can check out that data yourself. Subsiding of charging hazards at the moment. Here's the 1-year chart for the relativistic electrons. There is the 3-day chart that's measured by the GO 16 and 17, as you can see there. Pretty low to moderate levels here. Here's the forecast model. Expecting an uptick. I would say there'd be an uptick coming soon as well. Tend to agree with that. Here's a diagram of Earth Van Allen belts. Keep in mind distances are shown here in miles. And here's the total electron content forecast. And we're seeing some chaos once again, some very high levels and some unexpected high-density regions over places like North America, especially the Pacific Northwest, actually. Some surprising GPS errors likely to be occurring there. I'm going to let it play through a second time here. You can see some GPS errors over places like the North Atlantic and Greenland as well. And some very high concentrated areas of electron flux here despite relatively low overall levels of electron counts. You're going to see some big GPS errors, especially in the northern hemisphere. As you can see, most of those red blobs are north of the equator. Quite a bit of chaos happening there in the electron belts. Next, another diagram of the atmosphere to show you the 300-kilometer line, where the Ionosphere layer is located approximately. And here's your ionogram showing you vibrational frequency in megahertz. There's a lot of chemical reactions going on up there in the ionosphere and a lot of free electrons. This is the altitude approximately where the GO 16 and GO 17 attempt to measure their electron densities using radiography from their geosynchronous orbits. And we are seeing some anomalies, major high-frequency anomalies in the ionosphere. There's the latest image from 9:15, and you can see some odd shapes going on there. Here's the anomalygram, anomaly in megahertz from the 30-day median. This will show you high-frequency anomalies in blue, low-frequency anomalies in red. So some high-frequency anomalies happening here in places like southern South America and the Central Pacific especially. Also some in the North Central Pacific. And some wild swings there, going from low to high-frequency anomalies rather quickly there. So a bit of chaos happening. Also some rather long-standing anomalies happening down here in the around the border between the Atlantic Ocean and Southern Ocean. Anyway, there's the latest image. That's 9:15 Universal Time. There's the ionogram, and there's the anomalygram. It's time. Time for bonus features and chewing bubblegum. And I'm all out of bubblegum. Here's your ground-based solar observatory imagery from Lurmonth, Australia. It's hydrogen alpha imagery, and check it out. Filament Pierre-Marie may be leaving the corona as we speak. Filament Pierre-Marie, everybody. Next, your solar intensitygram. I've pressed refresh so you can see it happen. This is still beta-gamma class sunspot. That's still beta-gamma class sunspot. And that is an alpha class sunspot. So the likelihood of major flares is certainly still there, folks. Mainly from 2891, this one right here. There are the fields of 2887. There are the fields of 2891. And I don't even need to show 2893. It's fairly uncomplex. So next we've got the NASA GOES 16 SUVI imagery. And you can see filament Pierre-Marie up there in the northeast is still attached as far as we can tell. Pretty current data there. This is what we usually stream when we're streaming the sun live to Twitch, by the way. The GOES 16 SUVI in 304 angstroms. And we'll close out today's daily space weather video with the SDO 171 angstroms and colorized magnetogram imagery. Thanks for tuning in. Congratulations once again on realizing our channel exists. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network. Least Busted. Name it news.